Hello everybody. So today I'm going to be talking to you about the cosine rule. The cosine rule is one of your last ports of call if you're doing a trigonometry question. So I would use it for a question that has no right angle triangle. So you can't use SOHCAHTOA or Pythagoras theorem. And a question where you also aren't able to use the sine rule. So it's the very last one we look at using. The cosine rule uses one angle and its opposite side, and then we also have the two sides on either side of the angle. So the formula for the sine rule is the following. So we have a squared is equal to b squared plus c squared minus 2bc times the cosine of a. So it's really important that when you're using this rule that you don't get the different sides mixed up. A squared is out here by itself, right? And that's always the one that's opposite the angle we're using to get the cos of. So a squared is always opposite the angle we're getting the cosine of. And b and c don't really matter which one you choose for that, to be honest. They're pretty interchangeable. So here's our question now. We are given a triangle and we're asked to find one of the sides. Now that would be fine. Normally we'd look again at using the Pythagoras theorem or SOHCAHTOA, but it's not a right angle triangle. And we might look at using the sine rule, but actually we can't do that here because we have an unknown side and we have two unknown angles, so we can't match up sides with opposite angles. So we have to use the cosine rule. So the first thing we're going to do is write out what the cosine rule is. So a squared is equal to b squared plus c squared minus 2bc times the cos of our angle A. And then we can start filling in what those different values are. A squared is going to be x squared is equal to, again, b and c doesn't really matter which way you choose them. So we'll say 9 squared plus 11 squared minus 2 times 9 times 11 times the cos of 102. Now we'll start solving that out. So x squared again is just an unknown. 9 squared is 81. 11 squared is 121. 2 times 9 times 11 is 198, and the minus there makes it minus 198. And then cos of 102 is minus 0.208. So we can start simplifying things then a little bit more. 81 plus 121 is going to be 202. Minus 198 times minus 0.208. Well, the minus times minus will give us a plus. And then when we do the multiplication out, it works out as 41.184. Then we can just add what's left on the right hand side. 202 plus 41.184 is going to be 243.184. The last step then is just going to be to get x. So we'll get the square root of both sides. That will cancel out on the left hand side and just give us x. And then the right hand side will have the square root of 243.184. And that works out as 15.594 centimeters. Again, if this was an exam question, you just check the answer to see if they wanted to round it at this point to any specific number of decimal places. So now we'll look at a second example. In this one here, we're given a triangle with 3 sides given to us. We need to find one of the angles. So again, you'd normally think whether or not it's a right angle triangle, and then you'd be able to use Pythagoras or SOHCAHTOA, but it's not. We can't use opposite side angle pairs for the sine rule because we do not know any of the other angles. So we're left with no other choice but to use the cos rule, the cosine rule. So again, the first step is always to write out the formula. Again, you can find this formula along with any of the other trigonometry ones in your log tables. So it's a squared is equal to b squared plus c squared minus 2bc times the cosine of a. So if we fill that in with the question we've been given, a squared is always going to be the opposite side, so that's going to be 10 squared, and then the other two sides don't really matter what order you put them around in. So we can say 8 squared plus 9 squared minus 2 times 8 times 9 times the cos of that unknown angle A. So we'll actually just say that that's x here in keeping with the question. So again, the opposite side is A, so that's the one that's out there by itself. B and C, it doesn't really matter, it could be 8 or 9 and 9 or 8. Minus 2 then times BC times the cos for unknown angle. At this point now we have one unknown there, just our x. Everything else is something we can fill in and simplify, so we should be able to solve this with our equals. Okay, so first step is to simplify if you're solving any algebra equation. So 10 squared is 100, 8 squared is 64, 9 squared is 81, minus 2 times 8 times 9 is going to give you minus 144. Then we have the cos of x, which is still unknown at the moment. Now, we've got ourselves an equation where we've got our x, our unknown, just over there on one side. That's not a very nice x, but I think we all get the idea. So we're going to just follow standard algebra procedures, and we're going to try and get all of the constants, or 64, 81, and over 100, over onto one side by themselves, leaving our unknown there, the term with the unknown on it by itself on the other side. So 100 stays where it is, 64 comes over, becomes minus 64, 81 comes over and changes sign to minus 81. That's all equal to minus 144 times the cos of x. Again, we can simplify. So 100 minus 64 minus 81 gives us minus 45 altogether. That should be equal to minus 144 times the cos of x. Now we can start looking at more ways to just simplify this and get x. So the first thing to do is maybe get rid of the term in front of cos x. So it's 144 or minus 144 multiplied by cos x. So we're going to divide by minus 144 here to cancel that out. Now if we do that on the right hand side, we have to divide by minus 144 here as well. So these will cancel. And that will give us cos of x on the right hand side. And on the left hand side, minus divided by minus gives us a plus. And then 45 divided by 144 gives us 0.3125. Now the very last step that's left here is to try and get rid of cos. So again, we just want to get x by itself. So to get rid of cos, we're going to get the cos inverse of that side. Now the cos inverse of cos x we know is going to cancel out, but we have to get the cos inverse of the other side too. Okay, so again, cos inverse of cos x will actually cancel on the right hand side. That will give us just x, which is exactly what we're after. And then the cos inverse of 0.3125 is going to give us 71.79 degrees.